Okay, here's what we're going to do. I'm going to do this, show you guys how to do it today. That's it. That's it for today. That's what we're doing. Because I want to make sure you guys are cool on this. Because if you can understand this, which you can, then you can understand pretty much everything about the whole year. Okay, so we got acid combined with a base to form a conjugate base and a conjugate acid. So the acid in this case is water. Wait a second. Water is a base, it says here, and here acid is water. That's right. Water can act as an acid or a base, which is what makes water so special. One of the things that makes water so special. So anywho, Lewis drawing for water would look like this. We just have it memorized now, so we don't have to mess around. Lewis for the base, nitrogen brings 5, and the 3 hydrogens bring 1 each. So that's a total of 8 valence electrons. We're going to put the nitrogen in the middle, and then we're going to surround it with hydrogens. So that's 2, 4, 6, and we have 2 more electrons, and we're going to give them to the nitrogen. And now is the nitrogen stoked? Yes, because it has 2, 4, 6, 8 electrons. And all of the hydrogens are stoked, and we only used 8 electrons. So this is a good Lewis diagram right here. Okay, so here's the acid, here's the water. What's going to happen? I can't remember. Oh yeah, think bad thoughts. If this is an acid, what's it going to do? Donate a proton. And a proton is one of these H's without one of the electrons. So what's going to be left is oxygen and only 1 hydrogen. And then these electrons and these electrons and these electrons right here. Let's say this hydrogen is this one right here. I don't know. Let's say this hydrogen is this hydrogen right here. Let's say this hydrogen's gone because it got donated. These 2 electrons end up staying with this oxygen, but they just turn into a lone pair instead of a bond. Yeah? And then this thing now has more electrons than protons, so the whole thing has a charge of -1. That is a polyatomic ion, and its name is hydroxide. Yes? Fine. So its formula is OH negative, and its name is hydroxide. It's a polyatomic ion. Okay, and then this thing right here is the base. What do bases do? Bases accept protons. So this one is going to get one of those extra H's. So it's going to be like this. It's going to have 4 H's now. Essentially, this lone pair is going to be used to capture this proton right here. This proton. Doesn't matter which one. And the name of that's the ammonium ion. Its formula is NH4+. It's right here. It's the ammonium ion. NH4+. It's the ammonium ion. Yeah. Okay, fun. The previous 2 reactions illustrate one of the many amazing things about water. It can act as an acid or a base. How did the 2 reactions above show that water can be an acid or a base? Well, the first reaction, water acted as an acid. So it donated a proton. Yeah? And in the second reaction, water accepted a proton. And of course, a proton is the same thing as a hydrogen ion. Okay, speaking of water acting as an acid or a base, do this beauty. What in the woo-wood? The acid is water and the base is water. Now, it's not the same water molecule. We're talking about 2 different water molecules. So we're talking about a water molecule here. We can call this one Bill. And we got a water molecule right here. We can call this one Felicity. Yeah, Bill and Felicity. Bill's the acid, Felicity's the base. Okay, so if this one is acting as an acid, it's going to donate a proton. So over here, it's going to be the same, but without a proton. So it's going to be a hydroxide ion. Yeah, which is OH negative. And over here, this water is going to get an extra proton, so it's going to turn into hydronium. 1, 2, 3. 1, 2, 3. Dink, dink. This one has a charge of -1. This one has a charge of +1. And this one has a formula of H3O plus, and its name is hydronium. We're going to talk about this a bunch. The whole deal with the pH scale, and the pH scale is the way that acidity is measured. The whole deal with the pH scale is that it's measured by how much hydroxide there is and how much hydronium there is in the solution. More on that next time. All right, you guys, TGI Tuesday. Miss you again one day.